Good afternoon, students. In last class we have discussed regarding ionic equilibria, in that introduction to ionic equilibria, and then types of electrolytes, what are electrolytes, in that strong electrolytes, weak electrolytes, and examples for the strong electrolytes and weak electrolytes, and then degree of ionization we discussed in the last class. So in today's class we will discuss regarding factors pertaining the degree of ionization, and then we'll discuss regarding ionic constant. What is ionic constant? We will discuss in today's class. So, which are the factors pertaining to degree of ionization? The first one is nature of solute, and second one is nature of solvent, and third one dilution, and fourth one temperature. Nature of solute. When the solute is a weak electrolyte or a strong electrolyte, what happens to the degree of ionization we will discuss. When the ionizable parts of a molecule of a substance are held more by covalent bonding than by electrovalent bonding, less ions are furnished in a solution. So such substances are termed weak electrolytes. But in case of strong electrolytes, in which the transfer of electrons seems to be more or less complete, furnish ions immediately when dissolved. So strong electrolytes are almost completely ionized in solution. What happens to the strong electrolytes? They are completely ionized in solution. Nature of solvent. The main function of the solvent is to weaken the electrostatic forces of attraction between the two ions and separate them. The force of attraction holding the ions together in any medium is expressed as, it is given by F is equal to 1 divided by K into Q1 Q2 divided by R square, where K is called the dielectric constant of a medium. What is the function of the solvent? The main function of the solvent is to weaken the electrostatic forces of attraction between the two ions. Whatever the ions present, the force of attraction present between those ions, that will be weakened by the solvent, is the main function of the solvent. As a result, what happens when the electrostatic forces of attraction between the ions weakens, the ions will be separated. The force of attraction holding the ions together is given by the equation F is equal to 1 divided by K into Q1 Q2 divided by R square, where K is called the dielectric constant of a medium. So any solvent which has high value of dielectric constant has the capacity of separating the ions. Any solvent you are taking, any solvent which has a high dielectric constant has the capacity of separating the ions. So water is considered to be the best solvent. Water is considered as a best solvent as it has the highest dielectric constant. Why we are considering water is the best solvent for the ionization? Because water is the highest dielectric constant. And so on the basis of this, how you can conclude that means, what is the nature of the solvent? When the strong electrostatic force of attraction present between the ions, that force of attraction will be weakened by the solvent. This is the main function. When the electrostatic force of attraction present between the ions weakens, then the ions will be separated. So the solvent which has high dielectric constant is having the maximum capacity of ionization. So this is about nature of solvent. So next is dilution. The extent of ionization of an electrolyte is inversely proportional to the concentration of its solution. Listen student, inversely proportional to the concentration of its solution. Thus, degree of ionization increases with the increase of dilution. Inversely means it is inversely proportional to concentration, means as dilution increases, the degree of ionization increases. So the concentration decreases. So the term they have given, the extent of ionization of an electrolyte is inversely proportional to the concentration of its solution. As it is inversely proportional to the concentration of the solution means what? The degree of ionization increases with the increase of dilution of the solution. That is of decreasing the concentration of the solution. In this way, dilution plays an important role in case of degree of ionization. The given solution is more diluted, the degree of ionization will be more. Next factor is temperature. The degree of ionization increases with the increase of temperature. As the temperature increases, the degree of ionization increases. This is due to the fact that at higher temperature, molecular speed is increased, which overcomes the forces of attraction between the ions. As we know that the forces of attraction between the ions is less, the ions will be separated easily. So in this way, increase in temperature causes the increase in degree of ionization. Now, what is ionization constant or dissociation constant? So to explain this, according to Arrhenius' theory of electrolytic dissociation, the molecules of a weak electrolyte in solution are constantly splitting up into ions, and the ions are constantly reuniting to form unionized molecule. Therefore, a dynamic equilibrium exists between the ions and the unionized molecule of a weak electrolyte in a solution. So it was pointed out by the Ostwald that like a chemical equilibrium, law of mass action can be applied to such system also. So you can consider a weak electrolyte AB which dissociates into A plus B minus ions. Weak electrolyte AB which dissociates into ions A plus and B minus, and the equilibrium state is represented by the equation AB gives rise to A plus and B minus. Now apply the law of mass action. What happens? The rate of forward reaction is given by RF. RF means the rate of forward reaction is directly proportional to the concentration of AB. AB is an unionized molecule. Or you can write RF is equal to Kf into concentration of AB. Rate of forward reaction is equal to Kf. Kf means what? Velocity constant or velocity constant of the forward reaction. Kf into concentration of AB. Now the rate of backward reaction RB. RB means rate of backward reaction is directly proportional to the concentration of A plus into the concentration of B minus. These are the ions ionized. A plus and B minus are the ions ionized. They will reunite to form a unionized molecule AB. So RB is equal to Kb into concentration of AB into concentration of B minus. So RB is equal to Kb. Kb means what? Again the velocity constant for the backward reaction. RB is equal to Kb into concentration of A into concentration of B minus. So at equilibrium what happens? The rate of forward reaction is equal to the rate of backward reaction. So RF is equal to RB. We can write Kf into concentration of AB is equal to Kb into concentration of A plus into concentration of B minus, or you can write Kf divided by Kb is equal to concentration of A plus into concentration of B minus divided by concentration of AB, that is equal to K, where the concentration of A plus, concentration of B minus and concentration of AB are equilibrium concentrations of A plus ions, B minus ions and unionized AB molecules. Now, what is K? K is the constant. That constant is called the ionization constant or dissociation constant. Now we get the term K. This K is called the ionization constant or dissociation constant. To explain this, we have taken the dissociation of weak electrolyte as an example. And the ionization constant K has constant value at a definite temperature for a particular electrolyte. If you are considering a particular electrolyte, this ionization constant value is constant at a particular temperature, at a definite temperature for a particular electrolyte. Thus, the value depends on the nature of the electrolyte and temperature. Which value? The K value, the ionization constant value, depends upon the nature of the electrolyte and the temperature. Which electrolyte we have taken into consideration, depending upon that, the value of K depends. Now let us take 1 gram mole of the electrolyte be dissolved in V liter and its degree of dissociation be alpha. We can write the equation AB dissociates to A plus B minus. What is the initial concentration? The initial concentration of AB molecule is 1 divided by V, and that of A plus ion is 0 and that of B minus ion is 0. And the concentration at equilibrium, the AB unionized molecule concentration at equilibrium is 1 minus alpha divided by V, and that of A plus ion is alpha divided by V, and that of B minus is alpha divided by V. Now what we have to do, we have to substitute the values, substituting the equilibrium concentrations in equation 1. Which equation that is? That is Kf divided by Kb is equal to concentration of A plus into concentration of B minus divided by concentration of AB is equal to K. This is the equation 1. In this equation, we have to substitute the equilibrium concentrations. So we will get the equation K is equal to alpha divided by V. Why we have substituted alpha divided by V? Because the concentration of A plus ion, the concentration at equilibrium is alpha divided by V, and that of B minus ion concentration at equilibrium is again alpha divided by V, divided by 1 minus alpha divided by V. Why we have taken this 1 minus alpha divided by V? This is the equilibrium concentration of AB molecule. That is equal to alpha into alpha square divided by 1 minus alpha V, or you can write K is equal to C alpha square divided by 1 minus alpha. Consider this as equation 2. Now what is C? C is the molar concentration. And this equation 2 is the Ostwald's dilution formula. And in case of weak electrolyte, we know that weak electrolytes already. In case of weak electrolyte, alpha is very small. The alpha value is very small, and hence 1 minus alpha can be taken equal to 1. Where in case of weak electrolyte, we can take 1 minus alpha equal to 1. Then the equation 2 reduces to, the equation 2 will be reduced to alpha square is equal to Kv, or alpha square is equal to K divided by C, or you may write alpha is equal to root of kV, or alpha is equal to root of k divided by c. Consider it as equation 3. Thus, degree of dissociation of weak electrolyte is proportional to the square root of the dilution. In case of weak electrolyte, the degree of dissociation is proportional to the square root of the dilution. As already we know that the degree of dissociation is inversely proportional to concentration. As the dilution increases, the degree of ionization increases. As the concentration decreases, the degree of ionization increases. In this way, we will get the ionization constant K, and then the degree of dissociation of weak electrolyte we have discussed. Thank you, students.